Good morning. Welcome to e-learning. I am P. Saktivel, Assistant Professor, Department of EEE, Thandai Periyar Government Institute of Technology, Vellore. Today's topic, phase controlled converters. What do you mean phase controlled converters? Phase controlled converters converts the constant AC input voltage to controlled DC output voltage by employing thyristor as a switch. So here, in case of this phase controlled converters, input is the AC, constant AC input voltage is the input and controlled DC output voltage. So in between these two, input and output, we are employing the thyristors as a switch in order to control the DC output voltage. In phase controlled converters, the thyristors are turned on by the application of the gate pulse. In phase controlled converters, the thyristors are turned off or commutated. The commutation is also known as turning off of thyristor, are carried out by the supply voltage when reverse biases the thyristor, provided the condition that IA is less than IH. IA means anode current, IH means holding current. Whenever the anode current is less than the holding current, then only the thyristor will get reverse bias by the supply voltage. Natural or line commutation. The turning off, also known as commutation, the turning off or commutation of a thyristor by the supply voltage itself. Due to the supply voltage itself, if the thyristor is turned off or commutated, that type of turning off or commutation is called natural commutation or line commutations. Phase controlled rectifiers need no commutation circuit because it is naturally commutated. We no need of an additional devices. So due to this, these natural commutations are very simple, less expensive and widely used in industries where controlled DC power is required. Principle of phase control. Phase control of SCR means by varying the firing angle alpha, the phase relation between the starting of the load current and the supply voltage can be controlled. Always, irrespective of the firing angle, the supply voltage input cycle starts at 0 and one complete cycle ends at 2.5. But by controlling the firing angle, we can control the output load current starting. So that is known as phase control. Application of the gate signal is called firing. Firing means application of gate signal. Firing angle is defined as the delay angle after which the gate signal is applied, or SCR starts its conduction, is known as firing angle. So after that delay angle only the gate signal is applied. That delay angle is known as firing angle. Unless otherwise firing angle is given, unless otherwise the gate signal is not given, the SCR will be in off state. After the application of this firing pulse or gate pulse only, the SCR starts its conduction. So the delay angle is known as firing angle. Here the diagram shows the firing pulse or gate pulse. In this Vs is the supply voltage, input supply voltage is starts at 0, reaches its positive maximum at pi by 2, 90 degree, and 0 at 180 degree, negative maximum at 270 degree, and 0 at 360 degree. And the second waveform shows Ig, where Ig is the gate current. So after this delay angle alpha, so up to this angle alpha, there is no firing pulse is given. So after this delay angle alpha, we are giving the firing pulse. After this firing pulse only, thyristor starts its conduction. So this delay angle is known as firing angle. it is a circuit diagram for the phase controlled rectifier. So here this Vs, see this Vs is the source voltage, R is the load, V0 is the output voltage that presents across the load. So here the load and the source, that is supply, are connected by the thyristor switch. Here T is the thyristor switch. So by controlling the firing angle of this thyristor, the load current, phase angle of the load current can be controlled with respect to the supply voltage. Working of phase controlled converters, thyristors, also generally known as SCR, represented by capital T, is connected to load capital R and the voltage source Vs. This SCR will not conduct unless it is forward bias and gate signal is applied. So in order to conduct the SCR, it has to be satisfied two conditions. The first one is it should be forward biased. Even though it is forward biased, it will not start its conduction. After the application of the gate signal, only it starts its conduction. Up to the application of the gate signal, the forward biased SCR is in forward blocking condition. So in order to bring the thyristor from the forward blocking condition into forward conduction mode, we need to apply an gate signal. Application of this gate signal is called firing. During the positive off cycle of supply voltage Vs, the SCR is forward biased. If the thyristor T is fired at some phase angle alpha on the source voltage, it will be on because we applied the gate pulse, that is firing is started. So now SCR is turned on and it starts its conduction. So the conduction of the SCR starts after the application of the firing pulse, that is omega t equal to alpha. So this conduction continues up to phase angle 180. It will conduct from alpha to pi. Here the load is resistive in nature. So the load output voltage V0 and load current I0 will follow the waveform of the supply voltage. Whatever be the waveform of the output load voltage is same for the load current because the nature of the load is resistive. So this diagram shows the supply voltage, load voltage and load current waveforms. Here this Vs is the supply voltage waveform. Already I explained this input voltage waveform, source voltage and this firing pulses. So here after the application of the gate pulse, after this delay angle alpha, only the thyristor will start its conduction. Up to that, output voltage is 0. So at the application of the gate pulse, the thyristors are turned on and bring into the conduction state. So now whatever the input that presents across the output. So the input is connected to the output through the conducting thyristor. See here, this is the firing angle. So this waveform will appear as a output during the period of alpha to pi. Alpha to pi. So the input is connected to the load during the period of alpha to pi. But after this pi, the input supply voltage is negative. So due to this negative voltage, the thyristor will be reverse bias. That is known as line commutation or natural commutation. So already I told that this load is resistive. So the load voltage and load current waveforms are same. See here, V0 is the load voltage and I0 is the load current. So both are same for resistive load. Working by comparing the waveform of source voltage and load current. Now we compare the source voltage and load current, that is the first waveform and last waveform. We observe that SCR is turned on at a phase angle of alpha. So because the phase angle delay is because of the application of the firing pulse. Because of the application of the firing pulse delay only, the thyristor starts its conduction after the delay angle of alpha. If the firing angle is 0, here we have a firing angle delay of alpha. If the firing angle is applied at 0, then this output load current will also start at 0. So here you see it is shown in the dotted line. So the output load current and input supply voltage will both are same, that is both starts at 0, that is there is no phase angle difference between the input supply voltage and output load current. But if we apply the firing pulse at 90 degree, then at 90 degree only the load current starts. So there is an phase difference between your supply voltage and starting of the load current for alpha equal to 90 degree. The starting phase angle of load current is controlled by firing angle. So after omega t equal to pi, the thyristor gets commutated because of the load current becomes 0 and the supply voltage gets reverses. So during the phase angle omega equal to pi to 2 pi, SCRs are reverse bias due to the supply voltage, that is known as natural commutation or line commutation. Advantages of phase control: by using this phase control, the SCRs, we can control the output or load voltage. That is the major advantage of the phase control. Next, types based on the supply. If the phase controlled converters works on single phase supply, then that is known as single phase converter. If it works on three phase supply, then that is known as three phase converters. Now the single phase converters, single phase half wave converter. In case of the single phase half wave converter, for one input complete cycle, the output has one load current pulse. So that is known as single pulse converter. But the single phase full wave converter provides two output load current pulses for one input supply voltage. So the single phase fully controlled converters or full converter is known as two pulse converter. Also, single phase half controlled converter, also known as semi converter, also provides two output load current pulse for one complete input cycle of supply voltage. So the semi converter is also known as two pulse converter. Next, three phase converters, very similar to the single phase. Three phase half wave converter will provide three output load current pulse for one input supply voltage. So this three phase half wave converter is known as three pulse converter. Next one, three phase full wave converter or fully controlled converters. It has 6 load current pulses for one complete input supply voltage. So it is known as 6 pulse converter. In three phase full wave converter, we have two types. One is three phase fully controlled converter or full converter, and another one is semi converter. Next, three phase half controlled converters or semi converter. In this case, for one input supply of voltage, either we have 3 or 6 output load current pulses depending upon the firing angle alpha. If the firing angle alpha is less than 60, it produces 6 output load current pulses. After the firing angle 60, it produces only 3 output pulses. So this is the speciality of the semi converter. The semi converter is a 3 pulse converter, also a 6 pulse converter. Next one, dual converter. Dual converter has two types: single phase dual converter and three phase dual converter. In single phase dual converter, two single phase full converters are connected back to back, but in three phase dual converter, two three phase full converters are connected back to back. Back to back connection of full converters are known as dual converters. Applications: paper mills, textile mills, steel mills using DC motors, AC feed traction system using traction motor, electrometallurgical, mechanical process, reactor controls, magnet power supplies, battery chargers, HVDC transmission, UPS. Thank you.